Good day friends, welcome to another video in the Python Novice to Pro channel. In today's video, I'm going to show you how to write code for 4 methods in a single linked list. First, how to delete a node in a single linked list. Second, how to search for a node in a single linked list. How to sort a single linked list. And finally, how to return the nth node from the end of a single linked list. The precursor to this video is part 1 of the single linked list series. I will encourage you, if you haven't gone through that video, to do so now, because this part 2 of the single linked list will use code from that part 1. It depends on it somewhat. So let's start. How do you delete a node in a single linked list? I'll show you a diagram here that shows how we do it. For example, if we have 4 nodes A, B, C, and D and want to delete C node, we'll have 2 pointers, the 10 pointers that goes through all the nodes searching for C, and the previous pointer prev that is following behind it, so that when it gets C, it will know what to do. So when 10 gets to C and it says, okay, C is the key we are looking for, it tells the previous pointer to unchain, unlink from C, and then it will move its next pointer to the next of C or temp, which is D. Then you free C or temp from the memory. When you free it, it's discarded. You no longer get it. So let's code it. In this code there, you see I've created a single linked list from the code from the part 1 of our video. So if you want to get it, check out part 1 of the video. The link is in the description of this video, so you can check out the part 1 of the video. Now let's go proper to the coding. We'll delete a node from a single linked list given a key or data. So I'll call this our method delete node. I'll just give it a key. Part of one of its argument is a key. So what we do is that we'll start from the head node. We'll start searching from the head node. So we'll start searching from the head node, and we'll check if the key is at the head node. If temp is not none, if temp.data is equals to key. If the key is at the head node, that means we are removing the head node. So we'll just say let the head point to the next. Then we'll free the node. Free the head node. We'll free the head node. And we'll say we are done. So we are done. But if the key is not at the head node, so we'll start traversing the rest of the linked list. So we'll say here that why temp is not none. Let me put this in brackets. I don't like what it's telling me. Okay, let me put it so as to be sure. If temp.data is, that means when we are traversing the rest of the node, if the temp.data is key, we'll break out of the, we have found the key. We'll break out, we have found the key. Then what we'll do is I'll say previous node becomes, but if we have not found it, we'll move to the next by saying previous is equals to temp and temp is next. I'm sure you understand this code because it shows you how to traverse the linked list. So that's what we are doing here. So we are just searching to see if it traverses. Whether it gets the key or not, it when the loop breaks or when the loop finishes, there's either two things that will happen. It will find it in the linked list and it will break out of the loop, or it will not find it and it will run to the end. So we don't know which of the situations. So we check if at the end. So we'll check if we are at the end. That's what we'll do. We say if them is not, that means if we are at the end, we just print out a message. Key not in the linked list. Key not in the linked list. There will return because there is nothing to do any longer. Otherwise, if this conditional doesn't run, we found the key. We found the key. So we just say free it from memory by moving the previous to the next of them. Previous dot next, so them dot next. Then free it from memory. And that's it. We have discarded the linked list. Now let's try this out. Let's try this. Let's apply the code that we've just apply the code we just wrote. First, to apply it, I'll create the linked list object. I'll create the linked list object and I'll add 3 nodes to it. You see, I use the insert at position method. That's what we did in the first video. So I'm sure now this method is not strange. I'm going to insert 3 nodes. I'm going to insert 3 nodes. So let me print it out. So you see that I've inserted 3 nodes. Print content is also from the first video. You see, now let me remove node 8. Let me delete node 8. So you see how it works. You need a key, so I say delete, then I'll print out what is. You see, it will give you only 1 and 3 now. See here, first we had 183, now it gives 1 and 8, so I deleted node 8. So that's it. So you can also try run it on your own and try to see if you give it a node that does not exist, what it will tell you. That's another possibility. Now let's go on to the next code we need to implement. We'll say how to search for a node in a singly linked list. So in this code, we are going to search for a node in a singly linked list. It's all about traversal. Searching for a node is all about traversing the linked list and looking for which of the node has a key. It's very, very simple. Searching for a node in a linked list. So I'll call the method search for nodes. I'll give you the key. So we'll traverse. We'll start from the head. We are traversing it. We'll start from the head. I'll select current be self.head. Then we'll loop through the nodes. Loop through the nodes looking for the key. So I'm sure you are familiar with this. We did this a lot in the first video. Why current is not none. Why current is not none. If we have found the key, while looping, what do? We print out a message that we have found the key. Print out a message, then we'll return from the method. Otherwise, if we don't find the key on a given node, we move on to the next. And what it means is that we didn't get the key after looping. If we finish looping, that means we didn't get the key. So we print out a message. Printf node. So print out a message to that effect, and that means everything is okay now, and then we'll return. So that's the code. Now let's try it out. Let's try how to search for. Let me show you what we'll use the former application as before. This is what we have in our linked list. We have 183. Let me make this clear. So much distractions. Okay, we have 183 in our linked list. Let's search for 3. Let's ask it if 3 is. Just search for node if 3 is in the. See, to return that is in the list. No, 3 is in the singly linked list. They are returned. But let's say, okay, what if we say what is not in 5 is not in the node 5 is not in the singly linked list. Let's search for that. So it's node 5 not in the linked list. That's it for searching for a node in the singly linked list. Now, what's the next code we need to write? For how to sort a singly linked list. So the next code we need to write is how to sort. Okay, so in sorting a singly linked list, we'll use the insertion sort. There are other sorting methods that are more efficient, but this is just for demonstration purpose. That's why we are going to use the insertion sort. This is how the insertion sort works. In the insertion sort, we have our unsorted linked list. Then we'll build another sorted linked list that is empty. So we'll take an item from the unsorted list and put in the sorted linked list. As we are taking the item from the unsorted linked list, when we are putting it into the sorting, we'll be sorting it as we are putting it, checking if it's greater than or equal to, and putting it in the correct position. When we are finished transferring from the unsorted to the sorted linked list will be in sort order, whether from lowest to highest or from highest to lowest. But in this demonstration, we are going to sort from lowest to highest. So let's start. Sorting a linked list using insertion sort. So we'll call the method sort linked list. We'll call the method sort linked list. So first we'll create the creating empty unsorted, creating empty linked list to store the sorted nodes. So call it sorted list. Call it sorted list, and then we'll create an empty linked list. Then we'll start from the head of the unsorted linked list. So say is the current. We'll start from the head. Now we'll be looping through all the nodes, through all the nodes in the unsorted linked list, and we use a while loop to do that. So say while current is not none. So for the first, we'll say, okay, are we adding this to the head or not? Adding this to the head or not? We are adding. So we'll say we'll use a conditional and say if. So since this is the first, we are adding, but in the subsequent we might add or we might not add. If sorted list is none, that means nothing yet in the sorted list, or sorted list dot head dot data is greater than equal to current dot data. We create a new node and put it the current data we need. Then we say, okay, let the new node become the head. Because we are adding to the head in this stage of the conditional, and then the head recognizes the new node. That's it. I'm sure you are familiar with how to add to the head. This is just the code we add to the head. Otherwise, if you are not adding to the head of sorted list, we are not adding to the head, so that becomes our else. We are not adding to the else, so look for position to add it. Look for the position to add the current data. So to look for the position, we'll traverse the sorted list. We'll be traversing the sorted list, searching for a position. So while temp is not none and temp dot data is lesser than current dot data. What we are doing here is that we are saying now this current we have now in line 111, this current node, if we are going to add it, are we adding to the end or not? We'll make sure it's not the end and that is greater than the present position in the sorted list. So when those two are true, we just say create a previous that points to temp, then move temp. We move temp. So that's it. We'll keep on moving temp until we find a situation where it's possible to add. So if we get out of the loop, we found where to add. So we just say create a new node. give it the data of the current payload. Say okay, let the previous point to the new node, and then the new node point to the temp. So it keeps on doing this for each new current. So when it checks if it's the head or not the head, then we add. After we add, what it does is move on to the next. Inside the loop, we'll move on to the next node in the unsorted linked list. It move on to the next node. So you say current to become current dot next. That's what it keeps on doing. It just keeps on running this while loop from the unsorted to the sorted, adding at its various positions until we get to the end. So when we get to the end, it says return. Will now return the sorted sorted. Now return our sorted list. So you can see it's elegant. It's very simple. You can do it. Now let's see an example of how we can put this into practice. Let's say we have already created code to insert 3. So let's say, let me add another one so that we'll see. Let me put a payload of 2 at the 4th node. Let's see the node we have here as we are trying to practice this new code. We'll see that we have a linked list containing 1832. So we want to sort it. We'll sort it to be 1238. So I'll call the list. I'll call the object to say sort linked list. After sorting, I'll print it out again. So let me clear this before I run it, so you see this. So there's a problem somewhere. There's a code I didn't write very well, but to go through this and find where the problem is coming from might take time. But you can get the complete code from the link, because debugging this will take time. Just download the code I posted in the link at the description, so you can go through it and run it on your own. So let's move on. We return the end node from the end of a single linked list. That's the next code we are going to run. How we can return the end node from the end of a single linked list. It's very simple code. Let me just tell you how we are going to do it. Since we are returning the end node, what we do is that we'll create 2 nodes. We'll create 2 pointers. One, the one in front, the other one, the one behind. Then we'll say, okay, let's place, since we are saying, for example, if we have 4 nodes, we'll say return the end node, the second node from the end. That means the second node from the end will be node 3, because the first is 4, the second from the end is 3. So we'll say we'll place the 2 pointers, the one in front, the one behind, at n distance from themselves. So we'll place both of them at n distance from themselves. Now we'll say let both of them be moving simultaneously. Both of them will be moving simultaneously until the one in front gets to end. The one in front gets to end, you just retrieve the node for the one behind. That is just as simple as that. Get the end node from the end of a linked list. So we'll call the function end node from end. So we'll pass it the argument, the number of nodes from the end we want. So we'll just say the one in front, let it be at the head. The one behind, let it be at the head. Good. Now we'll place the one in front, end distance, place it in front pointer, and distances from the one behind. Okay, so say for I in range n, that means we are looping n times and we'll move it that n times. If in front equals to none, what we are doing here is we are saying, okay, as we are moving it, we are checking, have we come to the end? If we have not finished moving and we come to the end, that means n is greater than the length of the linked list. N is greater than the length of the link. It's just a precaution to make sure we are not searching foolishly. Then we'll return. Otherwise, if we have not come to the end, what we'll just do is that we'll keep on moving until we finish the loop. So at the end of this loop, in front will be n distances from behind. So now that in front is n distances from behind, we'll be moving them together simultaneously until in front gets to the last node in the linked list. Move both pointers simultaneously until in front pointer gets to the last node in the linked list. So use a while loop for that. While in front is not none. That means while we have not got to the end, keep on moving both of them simultaneously. Next, behind. Keep on moving both of them simultaneously. So when in front gets to the end, you just retrieve what is in front pointer now at the end. So you retrieve the data for behind the data. That's all. Now let's test it. Let's see what linked list we have here. Well, let me clear it because I don't like the screen. So we have 1832. Let me add one more. Let me add one more node to the linked list. Start at position 5. Let's see what we have now. We have 18325. So we have 5 nodes. I want to get the nodes at the second end from the end. if you want to get, we'll see that to return 2. Let me clear this. It will tell us is 2. Okay, I said return. Let me put print here because I was not calling it, so no need to put return. Let me put print here. So let's run it again. See, it give us 2. Or let's say the third node from the end. The third node from the end. The third node from the end is 3. So it prints 3. You can see it. If you want the fourth node from the end, to give you 8. So that's all for the codes for today. I hope you did enjoy the video. If you enjoyed the video, I'll encourage you to subscribe to this channel and like the video. It will encourage me to keep on producing more videos like this, so you can move from being a Python novice to a Python pro. I'll be producing more videos on data structures because I believe data structures helps one to grow to become a very good programmer. If you know the rudiments of data structures, you can easily solve programming problems because you know what structure to use. So that's why for some time now, I'll be concentrating my videos on data structure. So subscribe to this channel and like this video so you receive more videos I'll be publishing in the future. So thank you for staying tuned to this video, and I'll put the description on the link below. In the description of the video, I'll put the link to the code so you can run it on your own local machine. Once again, I hope you do subscribe to this video and like the video. Thank you. Goodbye.